Okay, so the first one, we have to think of how can I express 64 in terms of base 16 or 16 in terms of base 64. I really can't do either of them. But what base can I use? 4. Right. So I'm going to set up a factor tree. I get 4 and I get 16, right? 4 and 4. So you should get 4 cubed. Yeah, so 4 cubed, parentheses, 2x plus 4. I'm going to erase this part of it. This factor tree part. Okay. And then the other one, we get 4 squared. So 4 squared in parentheses 5x. And then what do we do with that 3? Distribute. Yep, so I'm going to distribute the 3 to each of these individual terms. So I have 4, 6x plus 12 equals 4 to the 10x. Now these are like bases, so I can set the exponents equal to one another. 6x plus 12 equal to 10x. Subtract 6x on either side. You get 12 equals 4x. 3 equals x. X equals 3. Questions on that one? Okay, cool. Number 2 is pretty challenging. So you have to remember a couple of things on number 2. So if you didn't get number 2, don't beat yourself up. Can I erase the first one? Okay, thanks. Okay. Clear. Alright, so the very first thing that we have to do, I'm going to leave myself some room, so I'm going to start over here, is I'm going to have to change that to 16 so that I have it in my numerator, right? So I have to have a negative 1. So again, the rule with fractions is to always change them such that you have a negative exponent. So 36 to the negative 3x plus 3 equals 216. So just use negative 1. And you have an x plus 1. Okay. So again, I have to ask myself, what common base can I use? Well, I can't use 36. The 36 squared is already bigger than 216. Yeah, I can use 6. So 36 is a perfect square, 6 times 6, and coincidentally it goes into 216. So I'm going to have to use a factor tree for that. So I have 6 squared in parentheses, and then I have negative 3x plus 3 on the outside equals. Okay, so what I wanted to do here before I changed that to 36 squared is I actually distributed, or 6 cubed, sorry, is I actually distributed that negative 1. So I have 216 negative x minus 1. Okay, now I'm going to change that to 16. So 6 times 6 is 36, times 6 is 216, right? So I have 6 squared raised to negative 3x plus 3 equals 6 cubed raised to the negative x minus 1. Okay. Now, I'm going to distribute. This is a good bonus problem, actually. So I'm going to distribute that 3. And then I'm going to distribute this too. So when I do that, I end up with 6 to the negative 6 plus, or negative 6x. Plus 6 equals 6 to the negative 3x minus 3. Now the bases are the same, everything's been distributed, so we understand everything up until this point. Okay? And then we just set them equal to each other. So, negative 6x plus 6 equals negative 3x minus 3. And then solve for x. So it's just a regular linear equation at this point. I'm going to add 3 to both sides. Remember, you can start wherever you want. So, continuing up here in the red, I have negative 6x plus 9 equals negative 3x. Add 6x, add 6x. 9 equals 3x. Divide by 3, x equals 3. All right. Again, that's a really good bonus question. If you got that correct, then you really understand this pretty well. If you didn't, that's okay. If you got number 1 correct, that's about where you need to be. If you got both of them wrong, then maybe spend some time looking over the notes, maybe watching the video. But if you at least got one of them right, then that's good news. And if you knew to make the 1 over 216 to 216 to the negative 1, then again, that's really good too. So as long as you got that far, that's good. If you didn't, that's okay. Just take note of that to study in the future. Okay, if you're not here, we are grading the assignment, so you can pause this and look at the answers on the recording. Number 20 says 1/8 is 2 to the negative 3, not 2 to the third. They solved for x, and they got x is 2. Okay, so the topic is geometric sequences. How can you use a geometric sequence to describe a pattern? This is 6.6. This is just like finding the common difference. Remember, we subtracted and we said, oh, you subtract 3 each time, or you subtract 2 each time, or 1/2 each time. Well, since we've been working with exponential functions and we've been talking about common ratios, multiplying by 2 or multiplying by 1/2 to get to each output, geometric sequences work the same way. So instead of finding a common difference, we're finding that common ratio. What is it that we're multiplying by to get to each term? So it says in a geometric sequence, the ratio, remember ratio is just a fancy way of saying the division. So for example, a ratio of 2 is just 2 over 1. Ratio of 1/2 is 1 over 2. The ratio between each pair of consecutive terms is the same. This ratio is called the common ratio. Each term is found by multiplying the previous term by the common ratio. So really, the trick is to just take the previous term and divide it by the one that precedes it. So 5 divided by 1 is 5, 25 divided by 5 is 5, 125 divided by 25 is 5, so the common ratio is 5. Any questions? That's really all there is to it. Alright, so to tackle something like A and B, you're just going to take your preceding term and divide it by the, you're going to take each term and divide it by the preceding ones, the one before it. So you're going to take 60 divided by 120, and you get what? 6 over 12, which is 1/2. Close. Now, and I'm glad you made that mistake, because you don't want to do this. You don't want to take 120 divided by 60, because then you will get 2. But then use some common sense. Each thing isn't doubling, right? So, since each thing isn't doubling, it's going to have to be the other way around, which is 1/2. Again, I'm glad you made that mistake, because a lot of people do that. And as you can see, you want to verify with each of the terms that you see on here that it is 1/2 each time. 60 divided by 120 is 1/2. 30 divided by 60 is 1/2. 15 divided by 30 is 1/2. So the common ratio 1/2. So it is geometric. So you would say it's geometric, the common ratio is 1/2. That would work as your explanation. Okay, 2, 6, 11, and 17 works the same way. Take each preceding term and see if you have a common ratio. Well, 6 divided by 2, that's 3. But then 11 divided by 6 is definitely not 3, right? So it's not geometric. So now you move on to, is it arithmetic? So 6 minus 2 is 4. 11 minus 6 is what? 5. So is it arithmetic? It's not arithmetic. And that is the way you say it, by the way. Yes, there's arithmetic, and there's also arithmetic. It's not arithmetic, so it's neither. So you would say neither, it does not have a common ratio, or a common difference. Question? That's all there is to that. So we'll practice a few. Alright, I'm going to go back here. If you're watching this on video, do give these a try. Determine if they're arithmetic, geometric, or neither. You can pause and then put them in your notes. And here are those answers for the 3 questions. The next set of notes is just the same thing. You're just telling me what the next 3 terms are. So they tell you that it is geometric, so you know that they are going to have a common ratio. You just have to find that common ratio. So what is the common ratio for A? 2. Yeah, it's doubling each time. 6 divided by 3 is 2. 12 divided by 6 is 2. So what are the next 3 terms? 48, 96, 192. 48, 96, 192. Alright. B is a little trickier. You see that it's alternating between positive and negative. So that is usually a clue that we will have a negative common ratio. What is that common ratio for B? Negative 1/4. Perfect. Let's take negative 16, divide that by 64, and reduce that. So when you reduce it, you do get negative 1/4. And you'll see that it is negative 1/4 each time. And you don't really have to check to see if it's the same ratio because you already know it's geometric. Because you already know it's geometric, you can just assume that they're all going to be multiplied by negative 1/4. So what's the next term? Positive 1/4, right? Because negative 1 times negative 1/4 is positive 1/4. And then 1/16. Negative 1/16. And then finally, what's the last term? Yep. 1/64. Alright, that's it for this section. We're skipping everything else. Do you have any questions? Okay. I'm going to put up the assignment. You have the rest of the period to work on it. For those of you that are watching the recording, let me put this on the recording. 17. We will likely have about 2 more items after this, maybe 3. So there'll either be 19 items or 20 items on your table of contents. I will go over, or I will show the previous page for the table of contents for those that were absent. Here is the previous page table of contents. I missed the bell work first period, so I included the bell work here, 15, 16. 16 was yesterday's assignment that we graded.